We recently learned about circuits on a small scale and talked about the current, the voltage, the resistance, and the power and how it all relates. Now we want to get into the mathematical relationships between all of them. How do you solve for them? How do they relate to each other? So here we go, physics fam. First off, if we talk about current once again, we know that the way to find current is just by taking the charge divided by the time. If you take those qualities and quantities, you are taking, well, Q we know is in coulombs, and time is going to be in seconds. So technically current's unit is coulombs per second, but we can also call that an amp. If we look at this practice problem, we can see that we're given a current of 5 times 10 to the negative third amps and 60 seconds worth of time. If we want to find the charge for that, simply use the current equation, and you can manipulate that to turn it into a current equals, it is a charge equals current times time problem. Amps times seconds gives you the coulombs left over of 0.3 coulombs. But that relationship of current is equal to the charge divided by time is something that you'll be expected to know. Now, if we move forward and we're going to get into something called Ohm's law, which relates voltage, current, and resistance, if you take a look and you hold resistance constant, meaning it's not going to change, as you increase your voltage, that means you're going to be pushing your current through even more so it's giving more pressure to push the charge through. Your current is going to increase. That means if you decrease your voltage, which is your electric potential difference, if you decrease it, you're going to also slow down the current, meaning that there's not going to be as big of a flow of electricity. Now, if you have the voltage not changing at all, so your electric potential difference doesn't change at all, then you increasing your resistance is going to slow down your current. The reason for that is it's going to inhibit the flow of charge. If you decrease your resistance, meaning that you're not going to inhibit the flow of charge as much, then your current will increase. So as you can see, there's kind of this tug of war with current in the middle, where resistance wants to slow current down and voltage wants to increase it. But that relationship between those variables is what we know as Ohm's law. So voltage is going to be equal to the current times resistance. And it's important to know what each unit and variable stands for, because sometimes people get confused simply by all the variables. So I is your current, it's measured in amps. V is your voltage, it's measured in volts. And resistance is the omega symbol, which is in units of ohms. If we take a 9-volt alarm clock, which is voltage, and we draw a current of 500 milliamps, which is really just 0.5 amps, we now have current and we have voltage. If we're looking for the resistance, we're looking for R. So using Ohm's law, simple enough, we can take the resistance and set the equation equal to resistance, so it's really just going to be voltage divided by current. If I take that 9 volts divided by the 0.5 amps, or 500 times 10 to the negative third amps, I end up getting 18 omega, which means 18 ohms. So you would say that as 18 ohms of resistance. The last thing we talked about and discussed in the previous lecture was power. Power is noted by the variable P. If you look at the three equations, power can be solved by taking current times voltage. It can be taken by taking current squared times the resistance, or voltage squared divided by resistance. As long as you have those equations, they're simple, easy plug and chug. Just make sure you know that power is in watts, current is in amps, voltage is in volts, and resistance is in ohms. Let's do one more problem to take this home and make sure we see all the relationships. If you want to find the power of a system here, so you have a current of 5 milliamps, which is really 0.005 amps. Remember, you just divide by 1,000 to go from amps or milliamps to amps. If you want to know how powerful it is, that's what you're looking for, the P. And you have a potential difference of 4 volts. That's really the same as saying voltage, the potential difference. So you have voltage, which is V, and you have a current. Simple enough, you can use the P equals IV, which means power equals current times voltage. Simply take your amps for your current and your volts, multiply them together, and you end up getting a power in watts, which in this case is 0.02 watts. So the relationships between the variables are pretty straightforward, especially if you have them all written out. So remember, your current is charge over time. Your power is going to be equal to current times voltage. And then, of course, Ohm's law is going to state that voltage is equal to current times resistance. As long as you know those and what each variable stands for, you should be successful at the very least with the math. Just remember that once you know your math, you have to make the connections with the actual ideas. So why, when voltage decreases, does current decrease? Why, when resistance increases, does current decrease? By knowing those relationships, you're going to have a better understanding overall of how electricity works. All right, thanks for listening. Best of luck.